Welcome to ANS Solver question 8 of this paper. So for part A1, they are asking us to sketch the sin x diagram. So you should know by heart by now the sin x graph, the tan x graph and the cos x graph, because if you put in the function into your table function into the calculator, you will not get a proper answer, because the calculator will give you the answers in terms of x and y, but over here you need your answers in terms of the degree. So you need to know the sin x, cos x and tan x graph by heart. So this is how the sin x graph looks. So you draw a curve like that, and the midpoint you have to make sure is at 180 and the curve ends at 360. So this is one sin x graph. Okay, now let's move to part A2, where they are asking us to describe fully the symmetry of the graph. So symmetry, it should have struck you that we have to first write that it has a rotational symmetry of 2. So we can say that it has a rotational symmetry of 2. This is because one of that when it is turned 180 degrees, the shape will look the same, and when it is turned 360 degrees, again the shape will look the same. So it has a rotational symmetry of 2. Now since this question is 2 marks, we need to give one more point to get one more mark. So what you can write is, you can write that the center of the sin x graph is 180 comma 0, and therefore this will be your final answer for part A2. Now let's move to part B, where they are asking us to solve for sin x minus 1 is equal to 2. So let's make x the subject of the formula. So for sin x will be equal to 3, because when you move negative 1 to the other side, it becomes positive 1. Therefore sin x is equal to 3 by 4. Therefore x will be equal to sine inverse of 3 by 4, because when you take a function to the other side of the equation, it becomes the inverse of the function. So sine inverse of 3 by 4, and when you do sine inverse of 3 by 4, you will get your answer as 48.5903. Now you need to get two values of x, and they are asking you between the 0 to 360 mark. Now you can remember this. It is very easy to solve this. You can remember this as the first quadrant is where all the trigonometric functions are positive. So you can remember this acronym as ASTC, which is all silver tea cups. So you can remember it like this. So S is where all the sine values are positive, T is where the tan values are positive, and C is where the cos values are positive, and A, of course, is where all the values are positive. So we have an answer from the first quadrant, that is 48.59. So all we need to do is round this off to 3 significant figures. So 48.59 rounded off will be 48.6, and this is because the fourth significant figure, which is 9, is greater than equal to 5. So it will round off the 5 to the next number. Now to find the second value of x, what you need to do is you need to see where else sine is positive. So sine is positive in the second quadrant, and in the second quadrant the value would be 180 minus x. So to find the second value of x, we can label it as x2 for now, is equal to 180 minus x1. So x1 is the value that we found as 48.6. So all you need to do is input 180 minus 48.5903 is equal to 131.4097. and therefore x2 will be equal to 131.4. So this is because your answer is in degrees. So degrees values you should try and give in one decimal place. Even the previous one, not three significant figures, my bad, one decimal place. And therefore 131.4 will be your final answer. This is because in this case the fifth significant number or the second decimal place is 0, and 0 is less than equal to 5, so it doesn't round off the 4 to the next number. Whereas in the previous one, 9 is greater than equal to 5, so it does round off the 5 to the next number. Therefore, your two values and your final answer for part B would be 48.6 and 131.4. Now let's move to part C. So in part C1, they are asking us to write a quadratic equation in a different form. Okay, so to do that first, we have to find the original middle term first. So how we do that is we use the formula half of the middle term, in this case it's 10, the whole square. So half of 10, which is equal to 5, and 5 square is 25. So your original, not the middle term, you don't have to find the middle term, you have to find the last term. That is my mistake, so I'll label it as L for the last term. So 5 square, which is 25. Now you can rewrite this equation. So x square plus 10x plus 25, and since we added 25, we will minus that 25 as well, because we don't want to change the equation or the expression. So minus 25 and the last term in the question, that is plus 14. Now we can seclude this part of the quadratic so that we can easily get a quadratic expression. So when we do that, you can use the formula of x a plus b the whole square, and when you expand it, it is equal to a square plus 2ab plus b square. So the a square term or the a term would be the root of x square, which is x, plus the b term would be b root of 25 in this case, so 5 the whole square, and you just take the sum of these two numbers. So 14 minus 25 is equal to negative 11, and therefore you have your values of a and b, and you can write this as your final answer, that is x plus 5 the whole square minus 11. Now let's move to part C2, where they are asking us that on the axes to sketch the graph y is equal to x square plus 10x plus 14, indicating the coordinates of the turning point. Okay, so as you know, in the previous question we found the same equation, and we changed it into a different form, in an easier form to plot for our help. So we can simply use the new equation. So we can use y is equal to x plus 5 the whole square minus 11. So while we are using this, we have to remember that my bad, the a value in this case, or rather not the a value, the minimum point can be found easily from this equation. So the minimum point would be negative a comma b. So in this case it would be negative 5 comma negative 11 as the minimum point, or you could say the turning point. So now all you need to do is roughly, again, because there are no values on the graph, so you can take negative 5, negative 11 anywhere on the third quarter, because third quarter is where both the values of y and x are negative. And you use a pencil for this because it is again a sketch. So negative 5, negative 11 could be around here, and again your graph, your point could be somewhere else, but you will get it correct as long as it looks realistic. So this would be a negative 5 point, this would be negative 11, and you can write over here negative 5 comma negative 11, and then all you need to do is draw a graph, and you can even find the points where the graph is intersecting the both the axes to make it look more accurate. So if you substitute x as 0, you will get your y coordinate as 5 square, which is 25. So I'll just solve it. So y is equal to 0 plus 5, which is 5. 5 square is 25, and minus 11. So y is equal to 14 when x is equal to 0. So your x-intercept, my bad, your y-intercept will be positive 14. So let's take that as here. Okay, and to find your x-intercept, all you can do is you will get two intercepts, obviously, because it's a quadratic equation. So you can simply input 0, or you can import this equation into your calculator. So 0 is equal to x plus 5 the whole square minus 11, and you can solve this equation. So my bad, you can simply go to the quadratic function in your calculator and input the values of the original equation, that is this. So x square coefficient is 1, x coefficient is 10, and the c value is 14. So you will get your two x values as negative 5 plus root 11 and negative 5 minus root 11. So negative 5 plus root 11 is negative 1.633, so that is somewhere over here, and negative 5 minus root 11 is negative 8.33, which is somewhere over here. Again, this is a rough sketch, so you can make the points on either side of the minus 5, and you don't necessarily need to do this, as it is again a rough sketch. This will just make it a bit more accurate. So you can go ahead and draw the graph like this. And make sure to make it as straight as possible, like this. So therefore this will be your final answer for question 8.